Welcome to the Fresno City College Psychology Department's video tutorial on the correlational method of research, focusing on helping you understand what it means to talk about the direction and strength of a correlation between two variables. We will not be discussing how to interpret correlations or the advantages and disadvantages of the correlational method. Those topics will be covered in other video tutorials. Let's preview what you are going to master in this video. For the correlational method, researchers do not manipulate any of the variables. They simply observe two variables in order to determine if changes in one are associated with changes in the other. Notice that I did not say if changes in one cause changes in the other. Correlation does not equal causation. This is not, however, going to be covered in this video tutorial. Another way of saying correlated is associated or related. Variables may have no relationship at all. That is, they may not be correlated. Variables that are related may have a positive relationship or a negative relationship. This is referred to as the direction of the relationship. A positive direction is called a direct correlation. A negative direction is called an inverse correlation. Variables that are related may have a strong or a weak relationship. This is referred to as the strength or magnitude of the relationship. Don't worry, we are going to go through all of this in detail with examples to make sure that you get it. When there is no relationship, there is no reliable tendency for variable x to go up or down with variable y. Another way of saying that is the value of variable x tells us nothing about the corresponding value of variable y. You will often see the values plotted on a scatter graph. Each dot represents how a participant scored on the two variables being studied. When there is no relationship, the dots are scattered all over the place. For example, there's no reliable pattern to the scores of depression and intelligence. If all I know about Molly is that she has an IQ of 100, I cannot use the data from my sample of participants to try to predict Molly's score on depression, because there is no reliable pattern. She might score very low on a depression scale, or she might score very high, or anywhere in between. Her IQ score does not help us make a prediction. In a positive relationship or correlation between variables, it is generally true that participants who score high on variable x are also likely to score high on variable y. And of course, this means that participants who score low on variable x are likely to score low on variable y. This relationship is referred to as a direct relationship. Variable x and variable y appear to vary in the same direction. You will often see a visual showing two up arrows or two down arrows. Here's an example. There is a positive correlation between the percent of the state population below the poverty line and the percent of the state population without a high school education. Let's look at this a bit more closely. The scatter graph shows data for all 50 of the United States from 2005 for two variables. Variable x is the percent of the population living below the poverty level. Variable y is the percent without a complete high school education. The straight line is called the line of best fit. It is used to show the data trend. In a positive correlation, there is an upward trend. That is, low scores on variable x are likely to correspond with low scores on variable y. Mid scores on variable x are likely to correspond with mid scores on variable y, and high scores on variable x are likely to correspond with high scores on variable y. We are not going to cover how to interpret these data in this video. We are focusing on what it means to say that a correlation is positive or negative, weak or strong. Notice that positive does not mean good. It is not good that the larger the population is without a complete high school education, the more likely they are to live below the poverty level. Positive refers to the upward direction of the data trend. In a negative relationship or correlation between variables, it is generally true that participants who score high on variable x are likely to score low on variable y. And of course, this means that participants who score low on variable x are likely to score high on variable y. This relationship is referred to as an inverse relationship. Variable x and variable y appear to vary in opposite directions. You will often see a visual showing one up arrow and a down arrow, or one down arrow and an up arrow. Here's an example. One study found a negative correlation between GPA and hours spent playing video games. Let's look at this more closely. The scatter graph shows data for research participants for the two variables. Variable x is college GPA. Variable y is weekly hours spent playing video games. The line of best fit shows the data trend. In a negative correlation, there is a downward trend. That is, low scores on variable x are likely to correspond with high scores on variable y. Mid scores on variable x are likely to correspond with mid scores on variable y, and high scores on variable x are likely to correspond with low scores on variable y. Let's talk about that r equals negative 0.84. We aren't actually going to go through the math, because that is outside the scope of this tutorial, but I do want you to be able to have a general understanding of what the number means. The number is referred to as the correlation coefficient. The correlation coefficient is the result of Pearson's R-test. Therefore, it is abbreviated as R. The correlation coefficient is a statistical measure of association that indicates the direction and strength of a linear relationship between two variables. It can only vary between -1 and +1. There's no such thing as a correlation coefficient of -1.2 or +3.4, for example. We already discussed the direction of the relationship. The direction could be negative, also called inverse, or it could be positive, also called direct. And of course, there could also not be a relationship at all between the two variables. When there is no relationship between the two variables, the correlation coefficient will be 0, or very close to 0. The stronger the relationship between the two variables, the further away from 0 the correlation coefficient will be. Stronger relationships help us make better predictions when all we know is an individual score on one of the two variables. Let's compare and contrast some correlations and their scatter graphs. Correlations of +1, usually just written as 1 because we don't usually show the plus sign for positive numbers, and -1 are equally perfect. Correlations of 0.8 and -0.8 are equally strong or high, and correlations of 0.3 or -0.3 are equally weak or low. You can see from the scatter graphs that the positive and negative correlations are mirror images of each other. Remember that each dot on the graph represents an individual score on variable x and variable y. And of course, correlations of 0 indicate no relationship between the variables. Perfect correlations of 1 or -1 indicate a reliable relationship between the two variables. That is, if we only knew an individual score on variable x, we would be able to reliably and accurately predict the individual score on variable y. This is very rare in psychology because human behavior is just not that predictable. But I'll give you a simple example. Let's say that there is a 5-day seminar that awards grades based solely on attendance. We have absences on the x-axis and grades on the y-axis. If all I know about Linda is that she was absent 3 times, I know that she earned a D in the class. Jill had 0 absences, so I know that she earned an A. Jake had missed all 5 days, so he earned an F. Jamal only missed 1 day, so he earned a B. Juan had 2 absences, so he earned a C. I could continue to provide you with the absences of students, and you would be able to make a perfect prediction of their grade in the seminar. It is a perfect negative correlation because more absences correlate with lower grades, as indicated by the downward slope. Of course, in this instance, We do know that there is a cause-effect relationship between attendance and grades, because that is how the seminar is set up. But in reality, is there a correlation between attendance and grades? A few years ago, I calculated the correlation for absences and grades. This slide shows the scatter graph that was generated from actual data from one of my class sections. You can see the line of best fit is showing a downward slope, indicating a negative correlation. Remember that each dot represents the number of absences and the grade for each individual student. For example, Greg was absent 17 out of 48 class sessions and earned an F, while Sally was absent only 3 out of 48 class sessions and earned an A. The correlation for these data is negative 0.688, which is a moderately high correlation. If we plotted attendance instead of absences, the scatter graph is flipped upside down. Saying Sally was absent 3 out of 48 class sessions is the same as saying Sally attended 45 out of 48 class sessions. The correlation between attendance and grades is positive. It is the opposite direction of absences and grades, but is the same exact strength or magnitude. Before we conclude, let's see how you do with some multiple choice quiz questions. Which correlation coefficient represents the strongest relationship between two variables? Is it 2.75, 0.32, negative 0.95, or negative 0.08? Pause the video now if you need some time to identify the correct answer. The answer is negative 0.95. Remember that there is no such thing as a correlation below -1 or above 1. So A cannot be correct. Also remember that the sign does not tell us anything about the strength. The one that is the furthest away from 0 in either direction is the strongest one. So the weakest one in our list of choices is negative 0.08 because it is closest to 0. Let's try another one. In general, people who report that they think about suicide a lot score higher on measures of hopelessness than people who report that they do not think about suicide very often. What type of correlation is this? Is it a positive correlation or a negative correlation? Pause the video now to give yourself enough time to identify the correct answer. This is a positive correlation. Remember, positive does not mean good. Positive describes the direction of the relationship or data trend. In this case, positive means that in general, the people who reported lots of suicidal thoughts were also likely to report lots of hopelessness. And the people who reported low amounts of suicidal thoughts were also likely to report low amounts of hopelessness. These two variables appear to vary in the same direction, which makes it positive. Let's do one more multiple choice quiz question related to data from Goals 2016 study on self-efficacy and mental health among professional students. This scatter graph shows the data points for the 100 students who participated in this study. They each completed a mental health index and a scale that measured general self-efficacy. Self-efficacy is the degree of belief one has in one's ability to achieve their goals. You can see that there is an upward data trend, but there is quite a bit of scatter. What best describes the correlation found between mental health and self-efficacy in this study, as indicated by the large amount of scatter and upward data trend shown in the scatter graph? Is it a weak positive correlation, a weak negative correlation, a strong positive correlation, or a strong negative correlation? Pause the video now if you need more time to identify the correct answer. It is a weak positive correlation. The actual correlation reported was 0.277. This concludes the Fresno City College Psychology Department's video tutorial on the correlational method of research, focusing on helping you understand what it means to talk about the direction and strength of a correlation between two variables. If you need more assistance mastering the direction and strength of correlations, please do not hesitate to ask for help.